Generative AI by Anjuman Chawla. So Anshu comes with a 15 years of experience in portfolio and program management, and she's expert in handling the development and maintenance project entire life cycle. She's also having a hands-on experience on Java web-based application in Agile framework. Anshuman, you can share the screen now.
Okay, good evening, everyone. I hope I am audible.
Yes, you are.
And I hope you can see my screen as well.
Yes, we can.
Okay, I hope every one of you had a good dinner and none of you are feeling sleepy. And I hope to have an interesting session and discussion with all of you. So I'll be your host for next 40 minutes. So this is Anjuman Chawla. And currently I'm looking into advanced development group in Samsung as a leader there. So today in my session, I'll be covering what is AI, machine learning, deep learning, and I'll be describing Gen AI application, how Gen AI works, and generative AI model types. So while we were discussing in this summit, today's day was mostly covered around AI. VCs, Supriya, Chandrasekhar, and even Pawan, they were discussing about different applications or different way to use Gen AI. But I was at the same place 2 to 3 months back, and then I started exploring what is this Gen AI? How is it technically taking care of the things? And then I learned a lot, and then I thought maybe I'll share it with this group. It may help everyone. So what is generative AI? Generative AI is a type of artificial intelligence technology that can produce various type of content, including text, imagery, and audio. But what is artificial intelligence? We have been talking about generative intelligence, but what is artificial intelligence? Well, when we are going to explore generative AI, we should have a basic understanding of what is AI, what is machine learning, and how they all are related. One way to think AI is a discipline like engineering, and all the other things are falling under it. AI is a science that deals with the creation of intelligent agents, which are systems that can reason, learn, and act autonomously. Essentially, AI has to do with the theory and methods to build machines that can think and act like humans. And it is basically making a system that can act like a human. I hope you all have noticed the word act. So it has been years, decades, we are working on AI, but we haven't been still able to make a system that is like human. We are still able to not replicate everything. Now, what is machine learning? In this discipline, we have machine learning, which is a branch of AI. It is a program or a system that trains model from input data, and that trained model then is used to make useful prediction from new or never seen data. Machine learning gives the computer ability to learn without explicit programming. In simple words, machine learning is a subset of artificial intelligence that focuses on getting machines to make a decision without explicitly programming them. So if you see here, now we have been able to explore the relationship between artificial and intelligence and machine learning. Machine learning is a subset of artificial intelligence where they learn on the past data. So machine learning are basically classified into two models, supervised and unsupervised. So the key difference between two is that supervised model, we have labels, label data that comes up with tag, name, type, or number. One way to understand label data is whenever we are making Excel, the top row we define what is that column referring to, name or employee ID. So you can think supervised learning models or label as that thing only. When we talk about unlabeled data or unlabeled data, so that is what unsupervised learning is. Right. So I hope the difference is clear. So let's explore them a little more. So the type of problem supervised learning can solve is shown in the graph. So where we have the minimum temperature and we are trying to predict the maximum temperature based on the past data. That is, we have the past data and in future we want to predict if this is a minimum temperature, then we can predict what will be the maximum temperature. That is learning from the past to predict the future values. Mathematically, if we want to see it, it will look something like this. So this is the most basic equation that I have taken, where y is equal to f of x, where y is the output. In our case, we were predicting the maximum temperature. So y is the maximum temperature, which is based on some kind of a model for a function of a x. X is the predictor variable or input. Let's say in this case, it was a minimum temperature. So basis some model, some coding on predictor variable, will be predicting the unseen variable of the value of the output variable. So let's get deeper into this. Why I want you to go into deeper of this, because we'll be exploring using these things more into Gen AI. So in unsupervised learning, the data is not labeled. Basically, it is not labeled, and we type of cluster them into different groups, right? And the example you see where we classify this group into 4 different type bases, bases their salaries, or let's say bases their states or something. So these type of problems are solved with unsupervised learning, where data is not labeled. So basically in supervised learning, we have input, which is fed to a model, and we predict the output. And if the output is very different from the expected output, then we get an error, and that error is then again fed to correct it. So this is a classic optimization problem. While it goes into the loop while we get the required answer or required model, which can predict the correct output. Unsupervised learning is where the input data X is fed to the model and it generates samples or grouping of the different data. So while we have understood what is AI and what are different ML models, supervised and unsupervised. So, but what were the shortcomings of this? So one of the shortcomings of machine learning was it was not able to handle high dimensional data. When I talk about high dimensional data, let me give you an example here. Let's just consider that you have a coin and you drop it on a single lane. You'll be easily be able to figure out where the coin is. But if it is a square plot, it will be little difficult for you to find it out. But when the dimension is increased to cube, it will become more difficult. What if the dimension is increased to n level? The complexity will keep on increasing. So similar is the problem of image recognition, where we have multiple different dimensions. So such problems cannot be solved by machine learning. The another limitation of machine learning is where we have number of data variables, right? So where the number of features or number of variables are more. So let us consider that equation that we have considered earlier, where y equal to fx. If the number of x are more, how will we consider which one is more important, which one is not very important? So it becomes very difficult for a programmer or a data scientist to tell the machine which feature is important, right? So this complexity keeps on increasing. Let us consider the case where you have 100,000 of predictor variables. How will you do that? So this becomes a limitation of machine learning. So to overcome the challenges of feature extraction, there was a need for deep learning models. So because the deep learning models are only things which were capable of learning to focus on the right feature by themselves, with little guidance from the program and without too much of programming. Basically, deep learning mimics the way our brain behaves. So in deep learning, what happens is feature extraction happen automatically with little guidance, and it learns the model. It will understand which feature or which variable is important and predicting the variable, and it will give us the required outcome. So deep learning uses artificial neural networks and are inspired from our brain structure. Now, when people started up coming with this deep learning concept, their main aim was to re-engineer human brain as our brain, and to re-engineer our human brain. When we are talking about human brain, it is very complex. The basic unit of a human brain is a neuron. Let's talk about what is neuron. On the screen, you can see a basic structure of a neuron, where these are the dendrites which receives input from other cell bodies, and some function is applied on this cell body axon, and then with some threshold, it is transferred to other parts of the body. So this type of neuron structure was replicated into the deep learning as well. So if you can see here, these are the input layers which receive signals from another neurons or another artificial neuron or perceptrons, and then some kind of input function or sum or threshold transformation is applied here, and then this is sent as an output to the other neuron network. So deep learning model basically has many input layers, which allows them to learn more complex patterns than traditional machine learning. And neural networks can use both labeled and unlabeled data. That is called a semi-supervised learning. In semi-supervised learning, a neural network is trained on a small amount of labeled data and large amount of unlabeled data. The labeled data helps the neural network to learn the basic concepts of the task, and unlabeled data help them to generalize to new examples. Now let us briefly explain where this deep learning fits into overall structure. So deep learning is a subset of machine learning where it just concentrates on the neural networks. It's a whereas machine learning is a broad field that encompasses many different techniques, and deep learning is a type of machine learning that uses artificial neural network, allowing them to process more and more complex information than machine learning. Deep learning or machine learning model in general can be divided into two subcategories. They are discriminative or generative. A discriminative model is a type of model that is used to classify or predict the labels of data points. And they are typically trained on a data set with the labeled data points, and they can learn the relationship between features and points. And it is generally used to predict the labels for new data points. While generative models generate new data instances based on the learned probability distribution of existing data, this generative model generates new content. Take this example here. For example, discriminative model learns from the conditional probability of the probability of y given the input x. Conditional probability is like whenever we have given the input x, what is the probability of predicting y? And while generative models take care of the joint probability of x and y and then predicts the conditional probability. So we have already discussed that deep learning is a subset of machine learning, and this generative AI is a subset of deep learning. So deep learning have basically two things that we have seen, generative and discriminative, and this generative is where we fall into the subset of deep learning. We have finally got where generative AI fits into AI discipline, and I think it can process both labeled and unlabeled data using supervised, unsupervised, and semi-supervised. So if you can see here, large language models, they are also subset of Gen AI and deep learning. So discriminative technique, as we have discussed, they are used to classify, and we have discriminative model, while generative techniques, they generate a completely new content, and they are so in older system, what we had data and label, which we fed it into the machine models, which predicts the relationships and learned the relationships between data and label, and then it predicted the variables. While in generative AI, it took unstructured content and learns the pattern in that content, and it generated the completely new content from it. So if you can see here, how to distinguish whether it is Gen AI or not. If we have the output as a number or a discrete or a class or a probability, then it is not generative AI. It is generative AI when we have completely new content. For example, image or a natural language or a audio or a text somewhere. So it is a generative AI. So this is our previous equation. So I think we have already discussed it. An example for what is not generative AI is when we are predicting whether a mail is spam or not, whether uh, the minimum temperature or whether we get the required climate changes or not. So such functions come under generative AI, not generative AI prediction, but when we are creating new, completely new content or summarization from the existing content, that comes under generative AI. So this is what we have seen. So to explain you the more power of generative AI, we have structured, unstructured content from which it builds a foundation model. This foundation model then generates a completely new content. So the completely new content could be text, code, or image. So these foundation models, they ingest lot and lot of data. For example, Palm or OpenGPT or Brad or some other tools, if you see, so they are kind of foundational model which takes lot and lot of data and then learn patterns on it, and then basis those patterns, they create a new content. So we have come up a long way from a traditional programming to neural networks to Gen AI. In traditional programming, we used to hard code whether if these are the features, then this is going to be the output. In neural network, we used to tell that if this is this, then this is the, then it is to predict output. While in generative AI, it used to take the inputs and then used to generate the output. So talking about the formal definition of generative AI, so so generative AI is a type of artificial intelligence that creates new content based on what it has learned from the existing content. It is the process of learning from the existing content is called training, and the results in creation of a new statistical model, which when given a prompt will predict and give us a new content. So large language model are also type of generative AI since they generate new content for us. So whenever we talk about generative models, at this point, we generally consider two models, language models and image models. In language model, it learns about the pattern in the language through the training data and give us, and then given some text, they predict what will come next. And while in image model, they take image and transform it into something else. And that something could be maybe they are captioning the image, or they are creating animation out of it, or a visual question answering. While for the text, it can translate, summarize, and even convert it into task and some other things. So as you discussed, generative language model learns about the pattern and language through training data and then gives what comes next. So let me give you an example here. Brad uses LLM, TLM, PAM. So whenever you try to search something, how to plan, let's say how to plan. So Google will show you the option basis your history. So this is also one of the example of generative AI where it is trying to predict what next will you type basis your work history. Right. One of the more use cases that that I generally see here is whenever we are having technical discussions, we generally forget the terms that are used in those meetings. So we can use generative AI tools for that. So for example, what is the difference between lambda and another we forgot? So we can come here and it can predict for us what is next. So these are the different responses. So this was the response from Brad. This is from ChatGPT. I like Brad responses more. So it can even solve philosophical answer. For example, what is success? So it will take an overall look at what is success and give us a example along with the example of explanation what is it. Now coming over to the fact how it works. So as we can see that it is a very complex functionality, right? The power of generative AI comes from the use of transformers. Transformers were produced in the 2018 revolution in natural language processing. At high level, a transformer model consists of a encoder and a decoder, right? So encoder and a decoder, the encoder encodes the input and decoders then decodes it and passes as the output. There are 6 encoder components, and similarly we have a 6 decoder component. This 6 is not a number, but it is a hyperparameter that was discovered in 2018 in a revolution. Each encoder can be broken into 2 sub-layers, self-attention and a feed-forward layer. The input to the encoders are first flows through the self-attention layer, which helps to encode and look at the relevant part of the word as it encodes a central word, and then to the second layer, that is feed-forward layer. The output of the self-attention layer is fed to the feed-forward neural network, and similarly, we have the decoder also. Decoder also has self-attention layer and feed-forward layer and self-attention, and there's one more component there, encoder, decoder, attention. Let's look at a little more detail here. So after we embed any input, it is passed on to the self-attention layer. The word at each position is passed to self-attention layer. Then it passes through feed-forward neural network. The exact same network at each vector will flow through separately. Dependency exists between these paths in this self-attention layer. However, feed-forward layer does not have these dependency, and therefore various paths can be executed in parallel while they flow through feed-forward layer. In self-attention layer, the input embedding is broken into query keys and values, which are then done using some functionality. They are embedded together, and you can see the Z that as an output, and which is then forwarded to feed-forward layer, which does some kind of processing on that input, and which is then passed on to decoder, and similar processing happen at the decoder level as well. So in GenAI, there's an important concept called as hallucination. So what is hallucination? These are the word or phrases that are generated by the models that are often nonsensical or grammatically incorrect. Maybe I'll give you one example here. A few days back, I was searching for a high profession job in OpenAI ChatGPT, and it gives me that all the high profession or high value job that are taken care by male. So there was a kind of biased data that has been fed into it, due to which it was giving us that result. So this is a kind of hallucination example. So why does that happen? Because model was not given enough context, and there were many constraints, or it has dirty data, and it was not given enough data to be trained on. There's one more important concept. I think Chandrasekhar has already covered what are prompt and prompt engineering. So prompt are basically the input that we feed into any Gen AI, basis which it calculates or it generates the output for us. So how good the input we give will predict how better quality output we will get. Right. There is two concept: prompt design and prompt engineering. Prompt design is the process of creating a prompt that will generate the desired output from the large language model of two closely related. And while prompt engineering is a practice of developing, optimizing to efficiency of language model for a variety of different applications. So prompt design is for some specific task, while prompt engineering is to improve the performance of some specific domain. So it's a vast field. There, prompt design is a more general concept, while prompt engineering is a specialized concept. While it can require prompt engineering is generally used when we need a high degree of accuracy and performance. So how we can make perfect prompt? Chandrasekhar has already given us example, but this is what I have come up with. We have to give a context plus specific information plus intent and a response format. For example, context could be, I'm a software developer and I want to work on a Python project. Explain how to implement exception handling in Python, and write the way I want it explained. Write it in a simple paragraph. For example, the output could be, you may need it in Excel or some other format. So you can specify that also. So if we keep this formula and request for input, so we may get the required output as well. So concludingly, whatever input we give, it forms a database. And when we input a prompt, it generates a new content for us. So different model types are text to text, where we can generate new content, or we can classify, summarize, or maybe we can ask for sentiment analysis as well. Text to images, we give us some kind of text. For example, in Delhi or Midjourney, we give a text, show me the beautiful eyes picture, then it will create an image generation or edit the images for us. Text to video or text to 3D where we give the text in few words and it will create videos or a 3D animation for us. And text to task is where we give input as a text and it will do a task for us. For example, this is the book, extract the summary and send an email to this. So it is referred to as text to task. So Gen AI landscape is huge. We have text, video, images, code, music, speech, and these are different categories that can be taken care into it. Though we can see that Gen AI has a huge scope and there are many things that we can do. But concludingly, I would say that it is only the tip of the iceberg that we are seeing right now. There is much more to come. So that's it from my part. Thank you so much for being a nice audience, waking so late. Thank you, SS Agile Guru.
Thank you for the great session. So any questions? We have time. We are on track. Any questions, audience? You can ask directly. You can raise your hand. I will unmute you and you can put it on the chat also.
So Anjuman, a quick question from my side. As of today, have you applied this GenAI on any products that you are building in your organization?
Yeah, Sharath, currently, I mean, with all this development in last November, so there's a lot of hype around Gen AI. So we have 2-3 projects that we are doing in Gen AI. So we are using the existing functionality, plus we are creating our own models as well here in Samsung.
So it's in banking or any other domain?
So it's not into banking, it's more of a informational domain.
Okay, informative. Okay.
Yeah.
Because personally, I've seen a lot of articles because I'm working with HDFC Ergo right now. We are into insurance.
Yeah, before Samsung, I was into insurance. I was,
right.
I was in Sun Life, but 3 years back, I switched over to Samsung and now I'm working with Samsung.
Yeah, because I've seen good amount of articles on GenAI, how it is going to revolutionize in insurance space. The kind of articles I saw, this going to create difference, at least, more than 50% in terms of cost, reducing costs, or, increasing the speed of delivery or automation, whatever we can do in terms of, instead of doing manual insurance claims and all, how we can automate that. A lot of insights I saw, so just want to check like which domain you're working on, so that probably I can connect with you offline to get more insights.
Yeah, I think I agree with you, Short. Insurance has a lot of scope. There are many processes and many more things that can be automated there, which are currently being done manually. So it has a larger scope there. But Samsung being very secretive organization, I cannot disclose much around that, what I'm working on.
That's great. Overall, it's a very great session because the last 4 speakers throughout the day have been talking about why part of it, why we need to do, right? Why we
Yeah.
need to adapt Gen AI or AI in different areas. Pawan was talking about how we can implement at the org level, but I think you took up how part of it, even though
Yeah.
technically you are not sound, but that is how I smelled it. Overall, it's a fantastic session. I think a lot of people might have already attached to your conversation. Thanks, thank you.
Thank
Uh,
you so much. Thank you for
anyone
giving
has
this
any other
opportunity.
questions before we wind up?
We don't have any other questions, so I think
Go ahead,
it's
Gaurav.
time to present the token of appreciation to Anjuman. I'm just sharing my screen. The screen is there now. So Anjuman, this is from SS Agile Group.
Thank you so much for giving me this opportunity. It was lovely talking to all of you.
Thank you. Satish, Sharad, you want to add something before I stop sharing the screen?
Thanks, Anjuman. Once again, a very heavy topic. You explained it in detail, and you made sure we as a participants or audience are engaged throughout the session. And definitely, we can understand that being a organization, we can't share what we are actually working on, but at least how part you explained it, and that was a very informative session.
Thank you so much.
Thank you. I'm stopping the screen now.
Thanks.